Thank you. Yeah, thank you. It's actually great to be here at NDC. We at JetBrains are working with NDC for years. Like we started with like .NET events, and we're still doing them. We enjoyed them, and I was so happy to learn when they started a C++ event in their like lineup. I was like, yeah, finally, that's great. Like the crew is fantastic, and the event's growing, so that's a good sign. So I'm happy to be here, and today we'll be talking about tools, because like I'm passionate about tools, like really. And it's not just because I work in JetBrains, that's probably the vice versa. I work in JetBrains because I'm passionate about tools. But also I'm passionate about C++. So that's why we will be talking about tools for C++, many of them. First of all, like, who am I? So yeah, I do work for JetBrains. For now, I'm head of marketing and business development, mostly working with game dev and .NET tools. But I started as a C++ developer before JetBrains. I worked for many years in embedded and telecom, and I launched the 4G network, which was lots of fun. When you work like with all this stuff in C++ and like many things go wrong, you know that. I do a C++ meetup in Amsterdam, so if you're anytime around in Amsterdam, you're all welcome to join us. If you want to speak, ping me. This is the QR code that leads to my LinkedIn. Join, connect, and let me know if you're around. Please, we really love speakers. We love new speakers. We love experienced speakers. Some of these people here already been to the meetup. Phil, have you enjoyed that? You should come. You should come. I know that Guy Davidson enjoyed it a lot already 2 times. So you see the speakers are returning. And we also do a conference. We started it just this year. That's a new conference. It's called C++ Under the Sea. You should get the joke. Like 75% of the Netherlands is below the sea level. So this is it. So come to Breda if you want to experience that. We'll have a great lineup of the speakers. The program is partially available on site, and we are rolling it out every week. There are new talks appearing, so you can check it out, and please join us. Anyway, so that's enough about me. Let's talk about C++ and tools. These are the topics we'll be covering today. So we're going to talk about the pain points we have in the language. And we're going to talk about how the tools are helping us with these pain points. Or if they're not, what's the reason for that? What's the issue for the tools to help us with some specific pain points? And so where are we moving further with the like era of LLM and like these big models? But before, like, I love adding the jokes to my talks, but I'm quite bad at jokes. But now I'm happy enough, because now I can ask AI to help me with the joke, you know? So I went to ChatGPT and asked a joke about specifically C++ and tooling. That was it. Why do C++ developers make great philosophers? Because after wrestling with the lack of tooling for hours, they start questioning the meaning of life, memory leaks, and whether their compiler even exists. Well, it looks that ChatGPT knows something about our pain points, right? It kind of fails us. So there might be something, because like it has no like own brain. It just trains on the data it has around in the like available in the internet. So probably ChatGPT learns something from the overall the internet about like what are the pain points for C++. Okay, so do we have a problem? Let's first discuss that. And actually, seems like we do. C++ Foundation every year does a survey asking people about the frustrating points they have in C++. And this is the table from 2024. And I have to say that the like lines in this table, they are there at the same places for 4 years already. Like nothing changes. No new things are actually entering this table, and even the order is the same. The percentage changes a little bit, like somewhere it's a little bit more, a little bit less, but you know that happens to the survey because the audience changes every year. So, but the list and the order and the priorities are the same. And I colored the table, you see that? So the color code is very simple. So the greenish lines are the things related directly to the language, the things we have when we're struggling with the language itself. Yellow is tooling. And like pink is everything else unsorted here. And you can see that like the top of the table is actually colored in yellow, which means the biggest pain points for the majority of the C++ developers every year for many years is tooling. whatever the language evolves, whatever the new tools the vendors are bringing to our tables, still tooling is the major issue. And you can see many things here, like libraries, build times, project models are in several lines. So there are many things. So maybe we can improve. Maybe we already have some tooling which addresses these pain points. And yeah, so tools are there on top for years. And let's see if actually we have tools to address these pain points. I want to stay a little bit apart for C++ for a short while and discuss this concept. I found it while I work in business development and marketing, so I do read various, creepy marketing books and management books, but sometimes there are some really nice gemstones in them. So one of that which I found is this concept of the candy, vitamin, and the painkiller, which actually started with the quote from this venture capitalist who said that we throw away the candy, we look at vitamins, and we really like the painkillers. And to the management, to the product, it actually usually applies in the way that vitamins is something nice to have, like extra benefits and features that enhances the products, but they're not essential. Painkillers are the must-haves, which solves the problems, and they're or the pain points. And the candy is like pleasure or fun to have, so some delightful and nice features. I kind of tried to reflect on that, how it talks to me in terms of the language. And I a little bit transformed it, so I added this cure. So I have now the cure, the vitamin, and the painkiller. And the painkiller here, in terms of the language, in terms of the tooling for the language, is a quick fix, a tool. So painkillers, they help instantly, immediately, right here, right now. It's still important to get vitamins and ideally eliminate the problem with the language change. But the word painkillers kind of has a negative connotation, right? So we're not usually very positive about that. But it does really solve the issue, but doesn't really solve the essence of the problem, right? So it just removes the pain. So that's how any of the tools work for us. But it helps, effectively. So what could do better? Vitamins, for sure, to prevent the issue. And the cure or the remedy to remove the issue from scratch. And we could recommend best practices, and we could force them with the tools. But better, we have the language which addresses the problem. So also, we do take painkillers with us, right, when we're traveling. I have a few with me in my travel bag. So we take the tools with us because we know they're useful. Don't forget your tools when you go on a travel, right? Okay, so talking about the language and how we constantly try to make it better, and these vitamins, and address the issue in the language itself. Actually, in C++, there are lots of things happening during the recent years when we're trying to make the language better, and sometimes we're even trying to create a new language. There are a few attempts in the recent years to make another language on top of C++, or to substitute C++ with some. It's not even the recent languages, maybe Rust was first, or whatever. So we have many attempts, some of them more successful than the others. Sometimes these attempts they look weird or sometimes promising, so it depends. One of the recent examples I learned, which really surprised me a lot in terms of how this new language is structured. So you know that C++ is widely used in game development. I mean, the whole Unreal Engine is written in C++, and all the AAA uses the C++. And these people are constantly struggling because the level, the entry barrier to this AAA gaming is very high, because it's gaming, it's all the ecosystem, and it's also C++, which doesn't help a lot in terms of the simplicity of the whole ecosystem. So Epic Games, who are the authors of the Unreal Engine, they are constantly looking for how they could lower the barrier, because they are struggling against Unity, which has a very simple scripting in C#. And they want to get to this audience too, but they have this entrance level, which is quite high. So they started working at a language called Verse. And as they, I talked to Tim Sweeney actually last week at Unreal Fest in Shanghai, and he was telling me this fantastic story that the Verse will be the language which kind of substitutes the constant C++ coding, so you will be doing everything in Verse and just rarely switch into C++ for some really tough stuff. And I was looking at the language, and it has this race expression, for example, and the race is used to run a block of 2 or more asynchronous expressions concurrently. And so the fastest expression competes, it wins the race. So the remaining are kind of the losers, and they are just cancelled. And so this is the code I found in the verse example in the Fortnite installation, which actually shows like 3 blocks. And in the third one, you can see in the very last line, you can see the indefinite sleep, which is there to guarantee that the first 2 blocks will win over the third one in this case. And I was like thinking, they were trying to create the language simple enough as a first-time programmer. That's how they positioned that. I taught kids at school. And I know that explaining them, for example, the concept of loop sometimes is very complex because that's like, a level up. So they have to understand what the loop is, that it constantly goes rounds and rounds. And I was thinking about how would I explain a first-time programmer what this race actually coroutine does. So given this whole concept behind that, I mean, coroutines are not bad at all. They're like good example of how we can get cool stuff in the language, especially for these concurrent executions. But it's not simple enough. If you just compare with the C++, I don't think it's really significantly simpler. So sometimes these attempts to simplify C++ looks like that. Okay, so we'll see how successful they are. They're gonna rewrite the whole runtime and release that in a couple of years and hope that all the game developers will switch to that. We'll see. But to me, actually, this kind of tools and techniques, especially this coroutine, looks like more a painkiller than a real solution in the language. Yeah, and this is like what the community thinks about it, that it even looks way more complicated than using just a regular C++. So we'll see if they achieve their goals. Anyway, talking about the tools, I want to tell you some small story from my past experience. So when I was working in the company, we were doing the software for the 4G and LTE networks, and we had a project, C++ project. Originally, it started with the make files, then we moved it to the CMake, and we had lots of different libraries, and we were packing these dependencies to build like a client software, a server software, and it was a huge CMake project with many, many components. And so sometimes when you're like trying to select a proper set of pieces to pack these dependencies and get your project ready for like further development, and you can do you can configure the CMake, and then you can like build the project. But sometimes you're like at the very first point, you're thinking about which dependencies should I take to build like my client software, for example, or which dependencies should I take to build my server software. And you have to select the dependencies, you have to cook the proper CMake, then like build it all, see if that's what you need, and then maybe start developing. So we're thinking about how we can just shorten the loop for our developers in the team so that they could start easily in the beginning of the day with their sub-project. And we just realized that we could take the project in CMake and just try and load it in NetBeans. And NetBeans will only call the CMake command for us. So it won't build the project, but it will only do the configuration. And that's like, if the project is loaded in NetBeans, that would mean for our developers that it's okay. So all the dependencies are in place, and you can proceed and you can start developing the project instantly. And it kind of shortened the loop for us so that we all were sure that we just open this project, the collection we prepared for further development in NetBeans, and if it works, then it's good to go. Like all the dependencies are in place. And it was a very nice moment when we realized that we could use NetBeans in a very unusual way, just checking that all our dependencies are correct because it calls the CMake configuration under the hood. That was a nice kind of painkiller for the development flow, which took quite a lot of time because the whole build on our project took about 10 minutes. So it's kind of a long coffee break in the beginning of the day. Tools actually do help with the language a lot, and I would like to share a few practical examples for C++, how the current tooling in our ecosystem helps with the language itself. So first of all, some very basic things, like we all have macros, we still have them. We try to avoid them as much as possible. I think we are constantly failing, we're still using them for many things. So we need just to accept that we have them and try to deal with them properly. So there are many, many tools now on the market which helps them with the macros to understand what is behind them. Because when you see this code, you know that's just a text substitution, but you want to understand what's behind that. And so there are tools which do show you like the whole substitution, or which could substitute you just the next step or the whole chain, and you can actually look at that and understand what's there like behind this macro. And when I first demonstrated this like small feature to Louis Dion, I think it was somewhere at ACC or C++ now, a long time ago, and he was working with Boost HANA, and he was like amazed because he realized that instead of like, compiling and looking at the whole like build outputs where everything is failing because something goes wrong, he could just open this window and just take a look at the whole substitution. And it's highlighted, it's formatted properly, so that's just the block of code which will appear in this specific place after the whole preprocessor substitution. Or you can unwrap this step by step and kind of debug these macros. And this is a great technique if you're working a lot with these kind of things. And like the more close to practice example, if you look at the boost macros, so you can actually take a look at this whole substitution. Yeah, it's pretty big. I don't want to see it in my real code. But if I want to understand what's actually happening behind this boost macro, I would look at this window and I will get this like kind of formatted and structured code, and I would maybe understand something about my code better. Another thing where the tools are helping a lot with the language is actually help with the overloads. You know that in C++, which is very powerful, we have not just like function overloads, we have operators on overloads. And the problem with the operators is that if you take a look at this operator, which we overloaded here, and then you go to the line where I'm printing something to the output, you can try and calculate how many different operators I'm actually using there. It looks all the same. It looks like I'm just outputting to the stream, to the output stream. So, but there are different operators there. Actually, the first one is this. This is the overloaded one, which I specifically overloaded for my fraction class. And then just a few more. So there is the string output and yeah, the character. So actually 3. So in that line, it was 3 different overloaded operators. When you look at them, they all look the same. And it might be an issue for you if you want to understand what's actually happening in your code and you see just similar operators all in the whole line, but they're not completely the same. So it's good if you can just ask your tool to help you, maybe to put a cursor on the operator, and that's what I was doing here. And like, yeah, so the similar operators are highlighted and the others are not. And you can also navigate to this overload by just clicking the navigate shortcut through this operator. So you can actually get to this overload, you can see what it's like actually doing, and yeah, like just proceed and decide if that's the correct overload, that's the correct operator you're using. So this kind of helps with the overloads. Another thing is the story about the name parameters. So we don't have them in C++, but many languages do have. And the reasoning behind that is quite simple, because that kind of increases the readability of the code significantly, and you do less mistakes with similar parameter types. There are many techniques promoted now, like how you can deal with that, like assigning different types, convert into different types. But it's sometimes quite complex, and you sometimes don't want to wrap with different types, even if they're like quite different things now packed to the same type, maybe to some basic integer. But sometimes you just don't want to create another type, but you want to see what the parameter is about. And also, like, for sure, the problem is when the declaration is far away and you don't see it, and like, good if you can navigate it or just see the signature. But generally, if it's far away, you might make a mistake because of that. And also with the default values, the problem is that it's also hard to define like several combinations of the default values, right? So there were several mistakes to solve that in the language. There are a few papers here and a few approaches. Most of them didn't succeed, and I really love the talk by the Richard Powell from CPPCon, where he's showing how you could like implement this concept from scratch with the named arguments. So lots of experiments on top of Boost. Some of them work, some of them are maybe quite complex, but generally you can deal with that without a language support. You can have a painkiller, you can have tools, and many of the tools now can do these hints, right? So they help you distinguish parameters of the same type by simply adding the name of the parameter, the name of the argument as a hint. So it's not a part of the code, it's just what your editor, your IDE shows to you, like this is the name of the parameter. And so you can get that if you have a hint saying height, but you're passing the weight, or no. So there's possibly some problem in there. So, and you can quite often tune that, so not to show it in some obvious cases, and sometimes you want them all the time. Sometimes our users requested once from us a very nice feature that they don't want to see the parameter hints all the time, but they want to press some shortcut, and then these parameter hints, magically appears and then disappears. So they are not bothered with them. The lines are not too long all the time, but generally they can get them and see them. So another place where these hints could help is actually the hints which shows you if it's a pass by value or pass by reference. So it's good to know when you're passing something, so what was actually supposed to be here? Were we expecting a reference here, or should we pass by value? So, and you can see that from these type hints as well, because the editor, the IDE which shows you this code quite often has the proper code model, so it has the whole AST, so it definitely knows what is there, like pass by value or pass by reference. So it could show you what is actually there. And the hints which are my favorites for sure are the type hints. And the type hints, they could help with just some basic cases like outer variables or the lambda types. But the best case I love about the type hints are the structured bindings. Because when you have these hints for the structured binding, you actually know if you're assigning in a correct order, if you're actually having the proper result in the end. Because if you take a look at this last line in this block, and you can see that there is constant I and const char C and D as a const double, and I'm assigning a tuple, and I definitely know what's going on inside. So these hints could be helpful with providing some information taken from the AST and just showing it to you. So you don't need a language solution for that. You already have a painkiller in your tool. Another thing where the tools are quite often helpful are the domain-specific languages, because we're not just coding in C++, right? In embedded, in gaming, in many other areas, we're usually using something on top of the C++. There are some other language, some concepts. And sometimes it's quite a big and powerful domain-specific language. Like in Unreal Engine, there is a whole language built for this reflection mechanism, because while we're still missing the reflection in C++, we are coming closer to that, but Unreal Engine is still replicating the whole reflection system and using macro approach to that. So they're still doing all these macros to replicate the reflection, and they have all these uClass, uProperty macros with lots of parameters inside, and these reflection specifiers. In a general C++ language, these are just text, because this is the text substitution. But for Unreal Engine developers, they are definitely not. So they mean something. That means, for example, that you should have some specific function in your code. And the tooling which is aware of this DSL, it could suggest to you okay, let me create these functions for you, or let me show you that you're missing these specific functions. And this is some meta information. It's not about the C++, right? It's about this Unreal Engine DSL. Similar story with Qt. So we're using all these Qt signals, slots, and all the concepts from Qt. And these are just this is the C++ code, but there is something on top of that, right? So explaining you what are the parameters, what is the connect function, what are the arguments, and sometimes you want to see the tailored code completion in these calls, to substitute only what you need here for your Qt code. And the good tooling could actually know that you're using this DSL, especially if it's not popular and widely known as Unreal Engine or Qt, and it could provide you the support for that. For sure, the tooling is helping us to deal with the guidelines. This is just the example from the Clang tidy with the core C++ guidelines. So when Bjarne was presenting the core guidelines, it was from him coming the idea that without a tool enforcing the guidelines, they mean nothing, because you will never use any kind of the guideline if you don't have the tools enforcing that on you. And so getting the tools, getting your like ID or code analysis tool or like some tools on CI/CD, which enforce the guidelines, is super important for like the essence of just adopting these guidelines, because otherwise like only a few brave people are using them, right? And if you take a look at how the people are using the code analysis tools to enforce the guidelines on them, we do the developer ecosystem research in JetBrains for many years, 7 years already in a row, and we do track how the things are changing in the ecosystem. So, and I'm for sure always tracking how the things are changing in C++, and so these are the examples like the data from 2022, 2023, and 2024 about which tools the people are using to enforce guidelines on them. And you can see that like less people are using the IDE building tools, more people are using this like Clang tidy, Clang format, or Clang analyzer, and their CI/CD case like Sonar is also growing. And we spotted that last year, and actually thanks to Bryce who spotted that in our data and commented on that, and he said that I think the decrease of the IDE provided analysis tools here is indicative of people incorporating static analysis into their CI. And that's actually what we see from our users' feedback as well. So we learned that we need tools. We started using them some time ago, and now we're starting to move that to the like pipelines in CI to make sure that everyone is running the similar, config and validating the code for the similar set of rules, which is very important if you're working in a team. So we talked about how the tools do help for C++. But is C++ really friendly to the tools? And I will tell you, really, from my opinion, not really, but we are doing much better than, say, 7 or 10 years ago. When I started talking about the C++ toolability at different C++ conferences, I remember like Herb coming to me and say like, you should talk more about that. You should like gather the vendors of the tool and talk to us, to the committee. And now we have this fantastic tooling working group, and like the people who do come to the committee meetings and discuss all these toolability aspects, because the story of the C++ modelers clearly showed us that we might have a great feature in the language, but without the tooling support, without the vendors agreed on some specific stuff, nothing happening. So like, how many people are using modelers here in real projects? No? Oh, I see a hand. Daniela, you're not counted. I know you're using them. Yeah, so this is what's happening when we have a lack of tooling, when we have a lack of agreement between the tooling vendors. So why C++ and like toolability are not always friends? This is my favorite example, which I show in every, I try to show in every C++ talk. It not always fits, but still I love it a lot. So the problem with C++ is that we have 10 ways of doing one thing, and they're all good and great. And you can use all of them. And yeah, sometimes like this is how I return 42 with a little bit of creepy stuff with templated parameters. And that's how I feel when I'm doing that. And I even created one new way after listening to Inbalslevi talk about the reflection in C++. So we might have another fancy way of returning 42 soon. But the idea behind that is that really, so there are too many ways of doing one thing, even a simple thing. And they are all good, so we can all use any of them. But we need to agree in every team on which approach we're using now, right? And why it's bad for tooling, because imagine you want to refactory code and you would like to extract the duplicates into like one function, right? So finding a duplicate is really a nightmare when you have things like that. Because you can like say substitute the variable names to find a duplicate. There are smart tools who can scan your code and understand like that, yeah, that's probably the same piece of code. But if you have a completely different way of writing and achieving the goal in the language, that kind of make the finding duplicates completely impossible. So you still can do some tricks like analyze the AST, but it's so smart that no one does that. And it even has more things like that. So if you look at the syntax style of the C++, you can see that there are many options. So take a look at the recent battles, and like if you enter any community, like go to Reddit, They love talking about many things. So AAA, like almost always auto, or where the cons should be, or what is the trailing return type, or what is the virtual keyword, how it should be used, is different in different like guidelines, like Unreal Engine and core C++. We put all these syntax style settings into one table in our tools, and it's not the full table, it's like twice longer. So there are many options you can configure in terms of the style of your language. And to be honest, they're all correct. So they're all totally fine. And that's just a matter of your choice. And if the couple of people in the team are using different choices, that's not good. The code would look very creepy. So you have to agree on the syntax style, and you have to get the tool which will enforce this style on you, which will say let's put the cons to the other location, or let's convert to the trailing return type, and we'll do that automatically for you if you get the piece of code in a different style. So that's why the tooling becomes super important, and we need to be able to do that in the tools. Talking about the tools and the language toolability, if you look at these two lines, one line is the list of declarations, and another line is the list of expressions. And for the tool to understand that, you need to do a very interesting thing. You need to do an infinite look ahead, kinda, because to resolve these ambiguities, you need to get to the end of the line, which could be quite long. I just put a few letters because I ran out of some letters I can easily type, but I can type more. So the parse tree depends actually on the very last element in the line. And that affects how this code is highlighted, how it's formatted, whatever. So the whole tree actually depends on that. That's a little bit mind-blowing, so never do that to the tools. You're not friendly to them, but that's what the language allows us to do, right? So that's maybe not the very best example in terms of the style and good written C++, but we can do that. So it could be more complex, and we could achieve the same level of weird code. So the biggest issue for C++ tools is, in terms of the language tools, is to parse them properly and to distinguish types from non-types. That's actually it in the nutshell. I would be honest, C++ is not the only language which has this kind of issue. No, we are not that unique. But it has it to this very high level, and actually quite simple code could be written and get these issues. Okay, so talking about the C++ toolability, let's take a look at the next example. So the parsing the code and understanding if it's a type or non-type usually depends on the resolve. And resolve itself is not that complex, but it might depend on the other things, and especially it might depend on the project model context. And the project model context is somewhere in the project model. Let me show you the example. So I have this piece of code, and it has this preprocessor branch, and it depends on the variable magic. And depending on the magic, I have either an X type, or I have a Boolean. In the if I'm talking about the K variable. So the K is either an X type, or it's a Boolean type. And the actual choice depends on this magic variable. And this magic variable is somehow defined somewhere in my project model. So the tool, the C++ language-based tool, to understand the code has to get into the project model, look at that, and say, okay, I know what this magic value is, and now I can decide if it's Boolean or if it's X. Okay, so the magic is in the project model. What about the project model? Maybe it's quite easy to deal with that. Well, not really. So if you take a look at the variety of the project models we have in C++, well, CMake is trending. We know that. It's it takes a lot of share in the C++ projects, but there are still others. There are MS-Build, very popular for game developers, and obviously on Windows. There is Makefiles, which are still super popular in embedded. CMake is growing there. These people start realizing that CMake is like much better. I wrote these creepy make files myself for many years. I know it's better to do an effort and move to CMake, but that's still an effort. And also there is like Bazel growing now, especially for people migrating all their code to monorepos. I saw that in, sorry, in the C++ community for quite a long while, for a couple of years, when the people are they are joining all their projects into one big monorepo, and then they start realizing that CMake is not good for that. So it can't deal with like proper caching and all this stuff. And so they're like, oh, there is a nice Bazel over there, let's take Bazel. And they're migrating the whole monorepo to Bazel. That's what happened to many companies just in front of my eyes in the recent couple of years. So, and we see the Bazel is like growing, I guess, specifically for these big projects. So there are quite many project models, and the tooling has to deal with all of them. So it has to know where to find this magic variable in like every other of them. And there are actually even more. So there's like Gradle, there is Xcode, CMake, AutoTools, Sconce, which is not there, like Mason. It just doesn't fit to the plot on the slide. Okay, so let's come back to the painkillers and these pain points. So we had this nice table. So which tool can we use to address any specific pain point? Let's take a look. So let's start with the first one, which is managing libraries. We, in developer ecosystem this year, we actually surveyed and asked our respondents which libraries they do use for C++. This is the top of the libraries they're using. And actually, these are quite popular libraries. So you can see Boost, obviously, here, OpenCV, Qt, OpenSSL, libcurl, and many, many others. So if you can deal with these libraries, quite likely you can deal with the majority of the libraries. And many of these libraries, they have, like, for example, the specific CMake files too, so that you can include them into your CMake project, even if the library itself is not a CMake based. Or the library is quite often moving to CMake to help you to adopt it to like your project, which is quite often a CMake project. But also, like, there is a story about the package management, and I think it grows more and more in C++ now, and we see the adoption of the VC package and of Conan, and the reduce of the libraries built as part of like your build or like compiled separately. So this is more or less in quite a healthy state right now. So we still needs a lot of work here. There's still a need, which is now like proposals discussed in the committee about unifying some things around this package management, right? So to think that to provide some meta information which is just common for all of them and they can rely on it, which is a very good direction right now to make adoption of these tools even bigger. And also, like, it's interesting, I was talking that CMake is quite popular. We actually have a tool in JetBrains which queries the GitHub based on a specific set of parameters and then just calculate some numbers for you. So I configured this tool to calculate the number of the C++ projects, C and C++ repositories, updated for the recent 4 years, with quite a decent number of stars so that they're not like abandoned or the pet projects. And I just calculated the number of projects where I found the CMake list.txt file somewhere in the project, maybe not on the top level, but somewhere at least. And it's 40%. So it's quite good for the open source ecosystem. So it's quite healthy, I think. So CMake is really trending there. I guess if I would calculate some other project files for other project models, I will also have see a good coverage there. So, and as I said, quite often the CMake is present there in the library, even if the library itself is not built with a CMake. There are some fine packages for CMake and some files and explanations how to build this library into your CMake project, which is quite good. Talking about the build times, which is the second pain point in the list, actually this is quite a new tooling which I guess Visual Studio presented last year, which helps with some build insights. So it has several windows. Some of them just provide you some build insights, like showing like files and include tree views to analyze and optimize your include usages. Some of them, sometimes there is include cleanup provided where you can optimize the unused include directories and transitively like use the headers. And also this nice include diagnostic, which actually allows you to view the usage and build times of your header directly in your editor. So which is also nice, so you can look at them in place. In our tools, we also have these things called includes analyzer, where you can also like analyze your includes and the like how they contribute to the overall build times. But also, interestingly enough, you know that you can actually profile your CMake. So because the build time is not always about like building the actual C++ code. If you have a CMake project, there quite a lot of time could be used for the like CMake step, for the configuration step, for generating of all the necessary files. And you can actually profile CMake. So if you just pass the profiling option to the CMake and say like Google trace something, so you'll get the profiling output. And like in C-line, we just provide a tool window which gets the result of this profiling and show you as a flame graph. So like regular profiling you used to do for the C++ code. And you can try and analyze which steps takes the biggest time in your CMake configuration and optimize that. There are like point number 3 in the list was the CI pipelines. It's not really about the language, but I think that's a very important problem. So the people see that it's hard to configure the pipeline, and given that they move like more code analysis to the pipelines, they are moving their like test execution to these CI/CD pipelines. I don't understand that they have more issues with configuring that, because the more you have there, the more things you have to configure, the more issues you will meet on the way. Actually, the tooling for CI/CD now is quite profound. It provides you many templates. Quite often, it provides you the integrations. I think it's super crucial to have like integrations of the like CI/CD with the IDE, for example, when you can see what's happening for every commit right in the place where you code. So, and there are quite lots of tools for that, and the visual tools which kind of shows you what's happening on your pipeline. Point number 4. Was managing the CMake. And I could get where this is coming. This is my favorite talk from Mateusz from C++ Now, where he was like doing a quest, doing a quiz on CMake for the first 10 minutes of the talk. And I would say I worked with CMake for years and I failed. Like there were some nice quiz questions like what would be the output, and usually based on how the CMake works with the strings and with the numbers and with the fantastic opportunity to get more than 2 values for your Boolean in this nice language. So whatever, I always thought that Boolean is just yes and no, but they kind of shake this, this stone for me. So watch the talk if you want to like have some fun with CMake and realize that you don't know it. Just really a good recommendation. But anyway, so you can deal with the CMake much better now. So CMake as a language could be treated as a proper language. So, and the tools could have many things to show you and to help with it, like you are just coding the CMake. So you could have the code completion, like this is just the screenshots from C-line where we have some code completion for CMake commands or like targets, and you can have the explanation for the commands when you start typing the command, and you get the code completion, and you see this documentation window, and you can actually understand. And this is taken from the official CMake documentation, so often there are examples, so you can scroll, see some examples, do some good CMake, which is like always good, and like there are find usages and navigation for all this stuff. So you can do that. So just work with CMake as with a language, not just with the text. That helps a lot, first of all. But also, you know that you can debug CMake. I mean, yes, debugging project model looks a little bit weird to all of us. I do understand, but that helps, literally. So you can do the proper debugging. You can put the breakpoint. You can step through that. You can see the variable names. You can like change them on the fly and see what's going on there, see the results. This works, this helps, use that. Like Visual Studio can do that, C-line can do that. Just debug your CMake if you're not sure about that. I mean, the advice itself, don't tell anyone in any other ecosystem that we're debugging the project model. This is good, this is helpful. You can also profile CMake, as I mentioned already. There are CMake presets, which is a great thing to have the unified configuration. I really recommend you using that. CMake file API helps a lot to all the tooling vendors. Before that, we were struggling a lot, but now we can just work with the CMake as a black box, and it's fantastic. And it gives us all opportunities like that. But also, like in the era of AI, you know, that AI actually knows a lot about CMake. Sometimes I think much more than I could learn about the CMake in like a year. It can help, and it can like suggest you some like good stuff. So if you're, for example, want to use an open source library and you don't know how to do that in CMake, ask AI, it knows. Because that's an open source library. Many people are already using that. So it knows how to use the library, just ask. Point number 6 in the pain points were the remote dev environments, which are quite popular, especially after the pandemic, when we all moved home and we realized that our environment is at work and the powerful stations are also locked in the office and you are sitting at home with some creepy laptop and you have to work, but you don't want to wait, so you just want some warmed up dev environment to be ready there. So these things are becoming more popular. There are many abilities for that. All the modern tools now more or less support different remote opportunities, so you can have dev containers, you can work in clouds, and I actually see how people are moving to these clouds a lot, to not just because they're at home and something is in the office, but because that actually saves time, money for the companies, and like all the things. And with the warmed up environments, when you can have one environment with everything already prepared, say the ID index may be calculated, all the libraries already there, the new person is coming to the team and they just start instantly with that. They don't have to wait. This is like just amazing. I skipped the 7th point because it's not the one for the tools, but I have the 8th point, which is important here, and it's about the language itself, about the thread, memory, and type safety. And I want to show you the painkiller which we have. I know that now in the language there are lots of efforts to address these things with the language itself, right? So to have some lifetimes, to have some ability to write safer code, and sometimes it even goes beyond the C++ itself to like other reincarnations of the C++ language. But for now, if you're writing in C++ and you stick to whatever you have, there are painkillers for that. There are tools which could help you. So there is a very powerful thing called DFA, so data flow analysis. It actually analyzes how the data flows through the control graph and makes some assumptions based on that. And this approach could help you with analyzing the things like that, so showing you that the local variable point to a memory which is out of scope, for example, because it knows that. And also, it can do like escape from the local scope. It's also visible through the DFA. So, and this data flow analysis is actually quite a practical thing. So it's implemented in like several tools. We have it in C-Line. I know that Sonar is also doing some DFA. So this is the thing you can get right here and right now and use that. Interestingly enough, so you can have the bound safety as well. So you can actually see that I kind of switched height and width here in the code by mistake, kind of. And the tool is showing me that the index is out of bounds, which is a typical error which I might meet in the C++ code. And also like things like use after free and delete, so they also could be found here. And I could actually wrap this, actual deleting of the pointer with any function, so data flow analysis doesn't work in the scope of the one function. It could work in the scope of the translation unit, so it knows which functions I'm calling, and even if I'm deleting the pointer inside some delete pointer function, it knows that. There are even some work around making DFA possible for cross-translation unit analysis. It's quite heavy. I saw only the Ericsson prototype at one of the LLVM conferences. So mostly the people are doing that inside the translation units. But it already brings lots of insights into your code. Also like the null dereferencing example here, for example. And again, so this is all happening in the translation unit, not just in one function. So the DFA is the powerful tool, powerful analysis, which helps you capture all these typical C++ memory safety issues. And you can find it now in like everyday tooling. So we kind of covered some things here. Some things are still not covered. They're mostly about the language or about some localization and some other stuff. I do hope that more tools are coming for that and will help with that. So tools build a safe environment for C++ developers where they can simply focus on ideas and code, and this is super important. And you know what else now in the world is trying to help you in the very similar way, trying to help you to focus on ideas and code and like delegate the rest to the tools? That's the AI. And I want to stop on that for a while and to first of all explain why AI is good. So we all heard a lot why AI is bad to many reasons, and some people are often like complaining, but first of all, AI is very good because it knows a lot about all the open source libraries in the world. There are tons of texts, Reddit threads, whatever, Stack Overflow threads about different open source libraries. If you're using them, AI will help you because it knows so many information about that you will never get it in like even a day of searching. It knows kind of good and bad practices. Sometimes, yeah, it has issues with distinguishing good from bad, but it knows all of them. But what is good is that when the tool, the smart tool, is trying to use the power of AI for you, the tool might know the context of your project. And this is very good and very powerful. All the tools which are incorporating, like, for example, the AI flows into your everyday ID coding, that means that they are sourcing your project context to this AI, to this LLM model. So that means that the AI actually knows about the project you are doing, and that's not that it's trying to steal your code. No, don't get me wrong. But it knows that using these libraries, you are, for example, building for these pieces of the hardware maybe, or you are using these practices, or you're relying on this syntax style. And it knows that, and it can generate the code, or it can update your code with that knowledge. And this is a very powerful thing. So let me just show you some examples. So with the knowledge of the open source libraries, AI could actually generate lots of targeted code. For example, here I was just talking to AI and asking to generate the code in the IHAN-based project. So it knows about the IHAN, it's the open source library. It could take all the code and all the knowledge in the world about how the IHAN is usually used and generate the code for me. Also, it knows the context of my project, so it knows which things I'm actually doing there in the project, and could generate some reasonably good code. There are still a few things to know and to be aware. So this is like how to use AI productively for your C++. And there are a few tips. The first one is quite basic, like be specific. So if I ask AI to create an array with some specific numbers, I will get something like that. But wait, I wanted a std array. Why I didn't ask from the very beginning? So, I mean, it's better be specific. It's better explain to what exactly you want to achieve from the AI. Another thing is that AI is generating some code, but you also have other smart tools. So the tip here is follow their advice. Like if there is some code analysis on top in your IDE and it suggests you some good stuff, just apply that. Don't like rely fully on the AI generated code. Like I'm like using some Clang tidy quick fixes here in this code to convert the for loop. And another thing is that AI could actually help you to refactor. So I could select this code and I could just say, okay, let's rewrite it and maybe make it a little bit better. And the AI is just suggesting me to rewrite the code, and I could apply that. Interesting thing is that, yeah, I will ask the AI here that there are some C++ algorithms, maybe we should use that. And it will suggest me actually the algorithm to be used here in the code. And the question might be, why in the first iteration when I ask AI to generate the code, it didn't actually suggest me these algorithms. It knows about the C++ algorithms. Why not to use them? And it's an interesting answer from the AI I got, which is focused on the following. So my goal was to guide you gradually from the basic concept of code and abstraction into more complex. That's the learning process. Sometimes it's more beneficial to start with simple concepts and gradually shift to more complex ones. Well, AI is not trying just to help us, it tries to teach us. I think we need to accept that and maybe learn from that. So, I mean, reiterate. Never rely on the AI and the first go. Reiterate. And that's what we actually constantly see in the prompts of our customers using our AI tools, that they are reiterating. They are re-asking the same things with maybe some details on top or based on the results they got. Like ask constantly to make the result better. And actually what AI is super cool at and super good at is on summarizing things, and that's not just about the text. You know that AI could summarize all the long Reddit threads or the meeting notes. That's amazing. But it also could write a documentation for your code. How good is that? So you're just sitting there drinking your coffee, and AI is doing a job for you because your manager asks you to document all the code. Well done, good, job done, we can go further. It could also generate the commit messages for you. So if you're bad at writing good English text, you can use the AI to generate the commit message. Why not? It can do that. Delegate. Also, what the more complex maybe thing which we're now trying to get from AI is to help with actual coding. It's not that easy as just generate documentation, right, or to generate some steps, but to generate some nice coding, nice code could be an interesting thing. But what I have here is even more interesting because this tap typing, like the duck typing, tap typing, because I'm simply pressing tab and the code is generating, is not done with the public LLM. It's done with the local model, fully on your local machine. If you're aware of, if you're afraid of sending your code to the public LLM, you can do that locally. Local models are trained already on different languages well enough to be able to generate the proper code for you right on your machine. And I have some table here comparing this completion, which we call full line code completion, which runs locally, with the AI-based. So yeah, it's just a single line, at least for now. It's maybe limited to just completion only and some basic stuff, but you don't need a public model. And I know that many companies are prohibited of using AI because they don't want to send their code to public AI and they don't have maybe money to set it on premises in their company. But you can do locally many things now. There is lots of local LLMs trained for many good stuff. And if you were amazed here with any of the features I was showing, most of them are available in C-Line. So there are these fantastic booth over there with the lightning wall, and these fantastic guys who would be happy to show you any cool stuff. We also have some nice hardware pieces, and you can just play with the code for them. And you can also ask me about any of the tools. And these were the things we covered today regarding the pain points, the painkillers, and the tooling. And if you have any questions, I still have about 1 minute to answer them. Thank you. Okay, any questions here? You can just raise your hand and ask. Okay, if not, then you can capture me here. I'm here for this day. I'm leaving back tomorrow, unfortunately, in the morning. But today I'm here. Come to me, talk, argue, whatever. I'm open to anything. Thank you.